This is SpaceTime Series 24, Episode 47. Coming up on SpaceTime, Russia quits the International Space Station, unwrapping a supermassive black hole, and Blue Origin's final unmanned test flight of its New Shepard launch system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Russia has announced that it will withdraw from the International Space Station in 4 years' time. The announcement by the head of its space program comes in the wake of new space agreements between Moscow and Beijing and simmering tensions between Russia and the West. The International Space Station has been jointly run by NASA and the Russian Federal Space Agency Roscosmos ever since the first modules were launched back in 1998. Roscosmos says its agreement with international partners runs out in 2024, and several space station modules have now reached the end of their service life. The Russian orbital segment of the International Space Station consists of 5 modules, which together essentially comprise what would have been the base configuration of the cancelled Russian Mir 2 space station. They include the Zarya Functional Cargo Block, which is actually owned by NASA, who paid for it, the Zvezda Service Module, that's the one which has been springing leaks venting atmosphere into space in recent times, the Pirs Docking Port, which is slated to be replaced this year by the new Nuka Science Module, and the Prekhal-Izlovlovno Docking Port, the Poisk Docking Port Module, and the Razvet Storage Module. Russia withdrew its support for the Lunar Gateway space station back in January. Moscow is now planning to build its own space station, with the Inertia Corporation already working on the first science power module for the new outpost, which is slated to be in orbit by around 2025 at a cost of around $5 billion. The Nuka Science Module and the Prekhal-Izlovlovno Docking Module will at some stage be moved from the International Space Station and added to the new Russian space station. Roscosmos says the new Russian station will orbit at a higher altitude than the ISS, allowing it to better view polar regions, which are important for Moscow because of the opening up of the North Sea route due to Arctic sea ice melt from global warming. Moscow recently signed a deal with Beijing to develop a lunar space station either on the Moon's surface or in orbit around the Moon, or possibly both. Moscow says it's also working on a nuclear-powered space tug designed to transport manned space flights to the Moon and Mars. This is SpaceTime. Still to come, unwrapping a supermassive black hole. And we take a look at the European Space Agency's Galileo satellite navigation system. All that and much more still to come on SpaceTime. Astronomers have simultaneously focused 19 of the world's most powerful telescopes on the M87 supermassive black hole, directly observing the monster at a range of different wavelengths. The spectacular observations, reported in the astrophysical journal Letters, provides new insights into the 6.5 billion solar mass black hole at the centre of M87, which is located some 55 million light-years away. M87 became an important part of history back in April 2019 when it became the first black hole to be directly imaged. However, that remarkable achievement by the Event Horizon Telescope was really just the beginning. Data from 19 observatories have been providing an unparalleled insight into this black hole and the system it powers. One of the study's authors, Kazuro Haida from the National Astronomical Observatory of Japan, says scientists knew the first direct image of a black hole would be groundbreaking. But to get the most out of this remarkable image, astronomers also needed to know everything else they could about the black hole's behavior at this time by observing it over the entire electromagnetic spectrum. The immense gravitational pull of this supermassive black hole powers jets of particles travelling at almost the speed of light across vast distances. In fact, M87's jets produce light spanning the entire electromagnetic spectrum, from radio and microwaves through to infrared radiation, across into the visible and ultraviolet part of the spectrum, and on into the highest energy X-rays and gamma rays. The intensity of the light across the spectrum gives a different pattern for each black hole. Identifying these patterns gives crucial insights into a black hole's properties, such as its spin and energy output. which together with its mass are really the only things we know about black holes. But even finding these things is a challenge because the pattern changes with time. Scientists compensated for this variability by coordinating observations with many of the world's most powerful telescopes on the ground and in space, collecting light from right across the spectrum. It was the largest simultaneous observing campaign ever undertaken on a supermassive black hole with jets. NASA's telescopes involved in this observing campaign included the Chandra X-ray Observatory, the Hubble Space Telescope, the Swift Observatory, the Nuclear Spectroscopic Telescope Array NuSTAR, and the Fermi Gamma Ray Space Telescope. Each telescope delivers different information about the impact and behaviour of the black hole. The new data, collected by a team of 760 engineers and scientists from nearly 200 institutions in 32 countries, helped astronomers better understand the deep links between black holes and their jets. The first results show that the intensity of the electromagnetic radiation produced by a material around M87's supermassive black hole was the lowest that had ever been seen. And that produced ideal conditions for studying the black hole from regions close to the event horizon out to tens of thousands of light years away. The combination of data from these telescopes, as well as current and future event horizon telescope observations, will allow scientists to undertake significant research into some of astrophysics' most significant and challenging fields of study. For example, the data will improve tests on Einstein's theory of general relativity. It's our best understanding of the universe on the cosmic scale. Currently, the main hurdles for these tests are uncertainties about the material rotating around the black hole and being blasted away by the jets. In particular, the properties that determine the emitted light. Other research has been looking at the origin of energetic particles called cosmic rays, which are continually bombarding the Earth from deep space. These deep space cosmic rays have energies 1,000,000 times higher than what can be produced by the most powerful particle accelerator on Earth, the Large Hadron Collider. The new data suggests that the huge jets launched by supermassive black holes like M87 are the most likely source for the high-energy cosmic rays. But there are still many questions about the details, such as the exact location where these particles get accelerated. Because cosmic rays produce light through their collisions, the highest energy gamma rays can pinpoint this location. And the new study indicates that these gamma rays are likely not produced near the event horizon. At least, not during these observations. A key to settling this debate will be comparisons between those observations, which were made in 2018, and the new data being collected this week. The jets are important because they transport energy released by the black hole far out beyond the host galaxy. And the new findings will help astronomers calculate the amount of power carried and the effect the black hole's jets have on the surrounding space-time. And this is SpaceTime. Still to come, we look at the European Space Agency's Galileo satellite navigation system, and Blue Origin carries out what may well be the final test flight of its New Shepard launch system. All that and more still to come on SpaceTime. More than 2 billion smartphones with users worldwide are now making use of Europe's Galileo global satellite navigation system. The €10 billion project went live in 2016. It was developed by the European Space Agency to provide an independent, high-precision positioning system so that European Union members don't have to rely on America's GPS, or for that matter the Russian GLONASS and Chinese BeiDou satellite navigation systems, all of which could be disabled or degraded by their operators at any time through a system called selective availability. Galileo was designed to achieve horizontal and vertical position measurements within a meter precision, and better positioning services at higher latitudes than other positioning systems. Galileo includes a basic service which is free and open to everyone. It also provides a search and rescue function, and if you need a high precision capability, there's one available if you're willing to pay for it. After the United States disabled its selective availability capability on GPS, both Galileo and GPS began cooperative operations, with the European Union agreeing to address concerns by Washington related to the protection of Allied and US national security capabilities. That's understood to mean preventing enemy nations from using either GPS or Galileo during times of war. The first Galileo test satellite was launched in 2005, with the first operational satellites placed in orbit in 2011. Each Galileo satellite is equipped with 2 master passive hydrogen maser atomic clocks and 2 secondary rubidium atomic clocks, all operating independently of each other. Right now, the constellation consists of 24 active satellites plus a bunch of spares, with plans to eventually increase this to 30 satellites. The constellation operates in 3 orbital planes at altitudes of 23,222 kilometers. Each of the 675 kilogram satellites carries enough fuel for a 12-year lifespan, and work's already underway on the next generation of Galileo satellites, which are expected to begin flying sometime after 2025. This report from ESA TV.
Europe's Galileo constellation is the most precise satellite navigation system in the world, delivering meter-scale accuracy. Its signals let us find our way on foot, by car, even in boats and aircraft. So how do Galileo satellites, thousands of kilometres away, tell you exactly where you are? Simply being so far away is part of the answer. The satellites fly in 3 orbital planes, 23,222 kilometres above Earth's surface. Anywhere on our planet, at least 4 satellites are visible at any time, the minimum needed for positioning. Each satellite emits a radio wave containing its transmission time and the satellite's own position. Because radio travels at light speed, the signal's distance of travel is measured from the difference between the signal timecode and the time the receiver picked it up. It's like working out how far you are from a thunderstorm by counting the seconds between a lightning flash and its slower thunder crack. Time is converted into distance. For useful positioning, this timing must be accurate to a few billionths of a second, the time it takes for light to travel 30 centimetres. Combine distance measurements from multiple satellites simultaneously and your position is pinpointed. A minimum of 4 satellites is needed, 3 to fix the user's latitude, longitude and altitude, and a 4th to double-check time. Your receiver is smart. It knows the expected locations of the satellites to cut signal acquisition time from minutes to a few seconds. And as Galileo signals are very faint, equivalent to a 60-watt light bulb shone down from space, they are based on complex codes identifying each separate satellite. The receiver has copies of all these codes, so can make its own full-scale replicas of faint original signals for calculation purposes. These are used to calculate your final navigational fix, boosting our economy and quality of life by letting everyone, everywhere, find our way.
This is SpaceTime. Still to come, Blue Origin carries out its final unmanned flight for the new Shepard launch system, and later in the science report, a new way to determine when a volcano is about to erupt. All that and more still to come on SpaceTime. Blue Origin has carried out what may well be the final unmanned test flight of its new Shepard launch system. The test included people being strapped into and later released from the crew capsule by ground crews as a dress rehearsal in preparation for carrying people into space later this year. The NS-15 mission blasted off from the company's Van Horn spaceport southeast of El Paso into hazy spring skies. The 10.5-minute test flight reached a maximum ascent velocity of 3,615 km per hour. The capsule carried the Mannequin Skywalker test dummy, along with a payload of over 25,000 postcards from Blue Origin club members. Following main engine cutoff and stage separation, the capsule eventually climbed to an apogee of 106,021 metres. That's 348,753 feet, well above the 100-kilometre Kármán line, marking the official start of space.
T-minus 10, 9, 8, 7, 6, 5, 4. Command engine start. 2, 1.
Go, New Shepard, go. Beautiful liftoff from our launch site 1 in West Texas. First milestone on our trip to space, max Q. That's when the dynamic pressure on the vehicle is at its maximum. The toughest point in flight for the vehicle. And max Q is confirmed. All right, right about this time in your flight, on ascent, you're going to max at about 3 Gs. We've noted it before. The max Gs that you pull as an astronaut on New Shepard actually is on descent. So here on ascent, it's about 3 Gs, and it comes on gradually as you go faster and get higher up there. Until, of course, main engine cutoff and separation, and that is when you get to feel those beautiful 0 Gs. We're waiting for that here. Next stops, MECO and separation. Coming up here on MECO, main engine cutoff. So far, a clean burn from our BE-3 engine. There it is, main engine cutoff. Everything appears to be nominal. And now separation as the vehicle continues its ascent towards space. We have passed over just about here the Kármán line, 100 kilometers or about 328,000 feet. And we're just waiting for the 2 craft to hit their apogee. There it is, apogee just at about 346,000 feet. So far, so good. Looks to be a nominal flight for New Shepard's 15th flight to space. We, of course, preceded the launch by what appears to be a perfectly executed astronaut experience rehearsal. While there are no astronauts on board today, that was a critical step towards our march towards first human flight. At this point, the booster is re-entering the atmosphere. It means it's going to have air pressure against which those aerodynamic surfaces Patrick and I were walking you through can push against to guide the rocket back to its landing pad. And to think this rocket will have peaked at almost Mach 4, and by the time it touches down, it's just going to touch down at about 8 kilometers per hour or 5 miles per hour. So relatively speaking, a nice soft landing. Critical, as we talked about reusability, the softer the landing, the quicker you can turn it around, right? You're not jostling the rocket, you're not jostling the hardware. You want to be able to flip it around nice and quickly. The aft fins, we also call them the pie fins because they're shaped like pie wedges. All right, there go the drag brakes. And there you see all the speed bleeding off of the vehicle and waiting for our BE-3 engine to relight. There it goes. Landing gear deployed. Oh, look at that smooth landing. And touchdown. Welcome back, New Shepard.
Oh my God, what a beautiful landing,
I think that was one of the smoothest landings I've seen of this rocket. It almost looks unreal. It looks like CGI. I know some of you on the internet seem to think that. Believe me, that is a reusable rocket that takes off and lands. What a beautiful landing.
It looks like it's ready to go again.
Yeah, just, put in those drag brakes, put in the wedge fins, fuel her up, let's go again. But until then, the show is not over. We do have the crew capsule here. On board, we have Mannequin Skywalker, as well as a couple of payload lockers filled with postcards from students from around the world. We are waiting to see the drogue chutes come out. They will be followed by the main parachutes. There go the drogues. And here come the mains. All 3 parachutes are out. We're looking for full inflation, and there they go. So far, so good. A nominal launch, nominal landing for the booster. We're waiting for the crew capsule to come into land. We're at about 1,600 feet to go, and a nice smooth descent at about 16 or so miles per hour, just at about 25 or so kilometers per hour. That is a nice smooth descent. Now, at 800 feet to go here, we should remind everybody that we do have the retrothrust system that kicks on just in the last moment. Basically, it just creates a nice air cushion for the capsule so that next time, hopefully, when you and I are up in that capsule one day, we are going to be getting a nice air cushion underneath the capsule. And touchdown.
You can just see it just as it lands. You see that puff of air and it kicks up all that dust, but it's just such a gentle landing right there.
A beautiful launch and landing for both the crew capsule and the booster. Team Blue, congratulations to all of you. What a day. You should be so proud.
The launch follows NASA's decision to use New Shepard for lunar gravity tests. These will involve test flights briefly spinning New Shepard to simulate lunar gravity and allowing NASA to test equipment and procedures for future moon missions. Blue Origin's developed New Shepard for space tourism flights, launching vertically and landing under parachutes, thereby providing a very different experience from their main competitor Virgin Galactic, which will launch their passengers using a horizontal takeoff and landing on a conventional runway, with a spacecraft being drop-launched at high altitude by an aircraft mothership. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that women who take probiotics, omega-3 fatty acids, multivitamins or vitamin D are testing positive for COVID-19 less frequently. The findings, reported in the British Medical Journal, are based on data from 372,720 subscribers to a UK self-reporting app. However, intriguingly, these results were only found in women. There was no such effect observed for men or for women taking vitamin C, zinc or garlic supplements. More than 3.1 million people have now been killed by the COVID-19 virus, and another 150 million have been infected since the deadly disease first emerged in Wuhan, China, and was spread around the world. Scientists have ruled out the long-accepted idea that a sudden outbreak of asthma cases, some of them fatal, across Melbourne back on November 21, 2016, was triggered by water in thunderstorms. The hypothesis was that the water in the air broke up airborne pollen, which is commonly suggested as the mechanism underlying thunderstorm asthma. Instead, the new models suggest that lightning may have played a role. The authors looked at mechanisms including mechanical friction from wind gusts, electrical buildup and discharge incurred during conditions of low relative humidity, and lightning strikes. Their results, reported in the journal PLOS One, suggest that these mechanisms likely all operated together in tandem with one another. But the lightning strike mechanism was the only one to generate a pattern of subpollen particles following the path of the storm, and also more accurately describes how the pattern of emergency calls for ambulances evolved after the storm. Scientists have found a new way to help determine when a volcano is about to erupt. Current telltale signs of pending volcanic eruption include increased seismic activity, changes in gas emissions, and sudden ground deformation. But accurately predicting eruptions is notoriously hard, as no two volcanoes behave exactly the same, and also because very few of the world's 1,500 or so active volcanoes have monitoring systems in place. It means at best, volcanologists have just a few days' warning. Now, a report in the journal Nature Geoscience claims satellite observations may lead to earlier predictions of volcanic eruptions months in advance. Researchers with NASA's Jet Propulsion Laboratory in Pasadena, California, and the University of Alaska in Fairbanks have used more than 16 years of data from the moderate-resolution imaging spectrometers aboard NASA's Terra and Aqua satellites to detect subtle but significant increases in heat emissions over large areas of a volcano in the years building up to an eruption. Scientists believe the heat increases may be caused by interaction between magma reservoirs and hydrothermal systems deep underground. Twitter is often referred to as the toilet door of social media, which is why it's not so surprising that a new study has found that if you really want to go viral on Twitter, you need to be negative. The findings, reported in the Journal of the Royal Society Open Science, looked at tweets from the pseudo-referendum in Catalonia in 2017. It found that negativity in tweets increased the chances that a tweet would go viral. In fact, each new negative word increased the average number of tweets by 3.46%, while each additional positive word decreased it by around 7.14%. The analysis also found that tweets from verified accounts were retweeted some 23.51% less than those from non-verified accounts. The Dutch newspaper De Volkskrant is reporting that the Chinese tech giant Huawei is able to eavesdrop on all conversations taking place on one of the Netherlands' largest mobile networks. The paper claims Huawei has a hidden back door into the network of a major Dutch telecommunications company, giving it access to all customer data. The report claims the Dutch intelligence agency AVED is now looking into the extent that the Chinese government is able to use this backdoor to spy on the government of the Netherlands and monitor phone calls and other communications. Arvid would not comment on the report, but said that it was undesirable for the Netherlands to depend on the hardware or software from companies from countries running active cyber programs against Dutch interests, and that included China and Russia. Australia's Competition and Consumer Commission has won a federal court ruling that Google misled users on how to turn off their location data tracking history. The courts found that because of requirements forcing people to check no and do not collect data in two separate settings, Google were able to continue collecting location history and web application activity on some Android and Pixel cell phones. With the details, we're joined by Alex Harovroit from ITWire.com.
Google, Facebook and other internet companies have long lived by the rule that it is better to ask for forgiveness than it is to ask for permission. And that's why companies will automatically opt you into something and wait for you to opt out, because they know that the vast majority of people won't opt out. And in 2017 and 2018, between the 9th of March 2017 and the 29th of November 2018, Google had two locations where it was asking Australians for the permission to track their location. And it didn't make it clear that the first one was a specific location history. The second one was web and app activity. And through web and app activity, Google was still able to get a whole bunch of information about its users. And so continue tracking them, even though you would logically assume that if you turn location history off, that your location would no longer be tracked. Now, we know that Google's business is all about hoovering up as much of the world's information as possible and making it easily organizable and searchable, but it is also tracking people across the internet, as other companies do as well. Google are not the only ones. And they can build up a profile on you, who you are, who you like politically, the sort of things you like to eat, visit, place you like to go, and they can build quite a profile about you. And clearly this disturbs people who wanted to switch the location services off. And in fact, as people are listening to this broadcast, iOS 14.5 will now be available, and it explicitly allows people to tell apps not to track them. And we've seen nutrition privacy labels, like those nutrition labels on the back of packages of food, where Apple is forcing developers to state in detail what they are doing with your data. And that caused people like Google to wait months before they updated various of their apps, and people like Facebook put full-page advertisements in major US newspapers to decry this upcoming change from Apple and how it could be bad for consumers. But then recently they've said, this could make us stronger. What doesn't kill us makes us stronger. There's a sort of viewpoint that they're trying to eat from both sides of the apple there, so to speak. But the whole thing is about privacy. We live in a world where your privacy doesn't exist anymore. And Ronald Reagan once said that, we shouldn't be the generation that tells our children what it was once like to live in a world that was free. And he was talking about the US. But equally, we should not be the generation that tells our children, our grandchildren, what it was once like to live in a world where people didn't know what you were doing every second of the day. And I think there's going to be, and I hope, there's going to be this huge revolution towards privacy and respecting it by companies to truly make sure that what's private stays private and isn't being on-sold to the highest bidder on the internet. The famous saying says, if the product that you're using on the internet is free, then you are the product, because they're collecting all this information and data about you.
And the iOS software update wasn't all that's new from Apple. Lots of new products released.
Yeah, so they launched a brand new iMac, 24-inch model with very small bezels. The iMac itself is 11.5 millimeters thin or thick, depending on how you look at it, with a new M1 processor inside. There was talk there might be an M1X or an M2, but not yet. That's the chip inside that replaces the Intel processor. And it comes in multiple colors, looks very cool. It even has a keyboard with Touch ID. And if you go to the apple.com website, you'll see plenty of information about it. The second product was an iPad Pro, the 2021 models, which also have the M1 processor. And so what really differentiates an iPad and a MacBook now is that the iPad, you can touch the screen, you can use a stylus, and you can use keyboards and mice. But iPads don't yet run Mac apps. Will Mac apps come to the iPad? I think we have to wait for the Worldwide Developer Conference in the middle of this year to find out. But Apple also launched AirTags, which is a competitor to Tile, and Apple is able to use the billion-plus iPhones and iPads and Macs out there to securely and anonymously track devices without Apple knowing or anybody else able to tap into that information. And then you can attach one of these to your keys, your wallet, your various things, and you can track them. And even if the device is, you left it on the other side of town, because there's normally a lot of people with iPhones and Macs, it can pick up those signals and tell you with precision where it is. Apple also launched a new podcasting app that also allows you to subscribe and pay podcast creators directly in an attempt to compete with Spotify. With Apple's iPad Pro, they also launched in the 12.9-inch version a thing called a Liquid Retina XDR, or Extended Dynamic Range Display. This has the same color calibration as the Pro displays that were like $5,000 plus $1,000 for the stand, and even $1,000 extra if you wanted the anti-glare. Those reference monitors, although they sound expensive at $5,000, competing ones from Sony were, in the $20,000, $30,000 range. So actually they were quite cheap. But of course, a giant 30-plus inch screen is not something you can easily take with you on the field. Now the iPad Pro 12.9-inch has the same color calibration. So you've got a production-ready device for photographers, videographers, anyone that has to work with ultra-precise colors. And they even have a 2 terabyte model now available. It's obviously at the highest price. The 1 and 2 terabyte models will come with 16 gig of RAM. The ones below that come with 8 gig of RAM. And the port on the side is now a Thunderbolt port. It looks the same as the USB-C, but this just opens up a whole range of professional applications, super fast data transfer and more. There was also a new Apple TV. This is using the A12 processor from a couple of years ago, but it's a step up from the A10 they used in the past. And Apple can even get you to put your iPhone to your TV screen, and it will use the light sensor on your iPhone to properly calibrate the output of the TV when you're looking at it through your Apple TV device. They have a new Siri remote that is back to silver, and at the top of the remote there is a little sort of a click wheel, but it's not a click wheel like on iPods, but you can swirl your thumb around the circular touch wheel and you can scrub backwards and forwards through video in a way that's much more intuitive than just holding down the button on the previous remote. And there's also a new purple iPhone 12, so an exciting day today.
That's Alex Zaharov-Reutt from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpacetimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.